Alright, here's our lesson, which is called rates of change. We're going to say two simple geometric problems related to calculus. Number one is the problem of tangents. I'll get out of the way in a sec. What is the slope? I'm going to draw a picture. I'll get a second to scribble through it. So I'll read that out. The problem of tangents. What is the slope of the tangent to a graph at point? So here's going to be my lovely picture. Okay, and for anyone here that's taken, no, we're good. Good. Okay, anyone here that's taken physics, why would slope be important to us? Velocity, right? Okay, and that's actually where oh my goodness, can't believe my mind's gone blank. Forgetting the creator of calculus, this is where my mind's gone. Sorry? Newton, that's the word. I can't believe this. That's where Newton actually came up with these ideas, was all through physics. He needed a way to get his physics across. The number one and the number two is going to be, what is the area? Under a graph. Between points A and B. I'm going to stop there. There's A and B. I'm going to tell you a quick little story about this and why they're related. Because you wouldn't think those would really be related at all. Haley and I were having a discussion yesterday about how to get the equation of a tangent. She said, well, just sub h in for 0, or was it h in for 0, or the difference between the 2 points to be 0. The problem is mathematically you can't do that. Okay, the problem is too what they used to do for calculus. They would use rectangles to find this area. So they'd make tiny little rectangles, and that's how they find this area. Until they were able to come up with something so infinitely small, or to 0, the distance between the rectangles was 0, you've got to get the exact area of it. But until they can find it, they weren't able to, so that's how they're related. All right. I will say the rate of change is so rapidly dependent variable changes when there's a change in
suppose we went there.
Thank you. Okay, if you're new to my class, you haven't had me as a teacher before, I'm normally note heavy the first 10 minutes or 20 minutes, then I do examples all the rest of the class. And that's how it goes. So unfortunately, there's a little bit of scribbling at the beginning of every note. So this is a scribble time, right? All right, I'm gonna do one more picture and then we're gonna do examples of the whole rest of the class. Here we go, are you ready? Have I lost anybody yet? This is just definition, that's all this is. Okay? I'm gonna let a few people catch up that are still scribbling. Good. Okay, so I'd like you, this diagram here, I'm just going to call diagram 1. I guess I should probably call it diagram 2 because it's our second one. Third one? Let's call diagram 3 then, however. Whatever, it doesn't matter, it's new one. And I'm just going to draw a curve on here. It doesn't have to be very detailed. Okay? Here's my x values. Here's my y values. If this function is f of x, then I have a point right here. Which I'm going to call point A on the x values. Good. Okay, this is the part where I need everyone's mind to open up. If I put you to sleep, this is how I need you to wake up right now. Tanner, I'd like you to try this if you can. If my x value on this graph is A, what is the y value? B? F of A, right on. Thank you, whole class now. You're exactly right, class. Okay, so we got that right. The equation's f of x. The point there's going to be A. The next one's going to be f of the y value is going to be f of A. All right. Just another one we need. We're going to give a second point. And I'm going to call the x distance from A to that second point to be h. Cecilia, I'd like you to be brave and give me a value for that second point. Just the x value is all we need. Plus h is perfect. So we'll see what we got there. It's just going to be a second point on here, which is going to be the distance between the 2 points. Okay? Now, hopefully, you see where I'm going with this. Where's the y? What's the y value going to be for the point over here on the left?
It'll be f of A plus. I'm not sure.
Just f of A plus h. Right? Because all I'm saying is, let's say A is 3 and h is 4. This would be like f of 7, right? That's all we're saying, right? It's just going to be f of no. So this is going to be f of A plus h. Now, let's finish this off, and then we'll get to our note. We'll get to our examples. I'm going to draw a line connecting those 2 points. Taylor, we did a lot of lines back in grade 10, didn't we?
Oh, yeah.
Going back to grade 10, how do you find the slope of a line given 2 points to recall?
Not like the y2 minus y1
It's
2 minus x.
very good, but you don't get off that easy, unfortunately, because I told you that yesterday. What's y2 and what's y1 going to be?
I don't know.
Okay, no problem. Yeah, go ahead.
Y2 would be f at a minus f of a plus h.
Good, I'm going to just write it the other way if that's okay.
Okay.
That would work as well too. And your way would work as well too.
Wouldn't it, wouldn't it be negative then, if I did it the other way around?
Right, the denominator would be negative.
Okay. So,
All right. Yeah.
okay.
All right. Brendan, sorry. What's the denominator going to be for my x values then?
A plus h.
Right on. Okay, so a plus h is the one of them. Now, there's one last thing I can start to fix up here. What's the last thing I can do to fix this up? Chris?
Get rid of the a's on the bottom.
Two a's. So my slope is going to be f of a plus h minus f of a all over h. Now, you might say, Mr. Sadler, this isn't new. I learned this last semester, okay? But what we're going to do is we're going to do exactly what Haley said in this course. For an instantaneous rate of change, we're going to cheat. And I'm not going to tell you why we can cheat today. We're going to allow h equal to 0. Okay, so really we're finding the tangent at one point. Why? Does somebody explain to me why it's cheating? Just simply not go. You can't divide by 0. And that's the thing that mathematicians always struggle with. How can you divide by 0? You can't. I'll tell you in the next few days how we got around that problem. Okay? So this is called the difference quotient. Now, I'm going to just hit pause on the video so I can yell at you guys for a sec, okay? I don't like hearing me yell at you guys. Oh, 12 minutes.